3, 2, 1, action. All right, hello everyone. It is 2020 and Luca and I are on board the International Space Station. We have two video cameras here pointing two different directions. We're almost getting a full 360 view here. And right now we are all the way in the aft part of the space station. We're on the Soyuz MS-15 that is docked to SM aft. This is the Soyuz that I'm going to go home on, but it is actually the one that Oleg, Skripochka, Jessica Meir, and Hazza al-Mansouri arrived on, and I'll go home with them. So right now I'm in the descent module of the Soyuz here, and this is the hatch between them. So we're all the way as far back as we could possibly get inside the ISS. And so here behind me are our seats and the parachutes behind me. I don't think we'll be able to get the whole camera in there. And then on the other end there is Luca, and he's in the living module, the BO, the habitation module of the Soyuz. Go ahead, Luke.
Let's give some coordinates, Drew. Right now, because we are in the aft side, the Earth is that direction, if I'm correct.
I agree with that, yeah.
The Earth is that way, the universe, the rest of the universe is this way, and behind me is the rest of the space station, what we call the central stack.
All right, there are a couple things that you want to point out there in the descent or in the BO?
Absolutely. So over here, this is where some of the systems are. We have the toilet, just in case we have to stay here more than a couple of hours during the ascent. We have ventilators and fans and our cleaning system so that we can scrub the atmosphere of the CO2. Over here we have a vacuum manometer, which is the way we measure the pressure in space. And this is what I'm holding on to. This is the docking module, which also turns into the hatch. So when we are coming in, we use this to dock onto the space station, and then it opens towards the inside. And this is the part that actually impacted the space station when we docked. Over here to my right, these are the actual systems. There are computers in here for navigation and computation. And then, nicely aligned, there are 3 spacesuits over here. One of them is yours, Drew. The other two are Jessica's and Oleg's. And there are a couple of things that we added since we arrived. We have 3 gas masks. These are in case we have an ammonia leak on the space station for emergency. We have to fly to our spacecraft in order to come back to Earth as soon as possible. And so we have ammonia mask to get in order to survive. And emergency procedures, the daily descending instructions. These numbers let us know how to quickly come back to Earth in case of emergency. In this container there is food. This is again just in case we have to spend a couple of days up here inside the Soyuz on the way to the space station. None of our crew had to use it, but there was food in here. And apparently there is also a little happy birthday balloon from when we celebrated the birthdays. So we can start traveling back, and the next stop is going to be the entrance into the SM, the service module, which is the heart and soul of the Russian segment. Interesting thing, with my crew, so Drew and I and Alexander Skvortsov, we both arrived in this location and then we maneuvered to a different location. So as we move towards the SM, you're going to fly the same way that we did as we ingressed to the space station back in July 20th of 2019.
Luca, you hit the lights and I'll just fly through in the dark.
Yeah, I'm going to turn off the lights so that we save some energy.
Okay, I'm flying toward you.
Hi Drew, why don't you give me a description of where we are?
Okay, well, we're in the service module of the Russian segment, and this is a design that the Russians have used in their space program now for decades. It's very similar to the Soyuz spacecraft or the Soyuz space station, as well as Mir. And there's the docking port back there. Here's the toilet over here, the ASU. It's all decorated for Christmas. Alexander Sasha Skvortsov decorated the KTO, which collects solid waste. It says Snovum Godum, which means congratulations with the new year. And then there are 2 crew quarters back here on either side, and our 2 Russian cosmonaut crewmates, Sasha and Oleg, live in these 2 cayutas, they call them. And they spend most of their day back here working in the Russian segment. There's a table here that we share. They have all their meals, and when we have meals together, we have at this table, and they put tape on it to hold things down. Their water dispenser, and then
Some Christmas decorations.
Yeah, still Christmas decorations up because we're just making it through the holiday. This looked very familiar to us because the simulator in Star City is an identical exact replica of this, and so when I showed up in here, it felt like exactly like being in the simulator back there in Star City. It's perfect.
It's uncanny how similar it is.
Completely. They have a lot of their camera equipment mounted on the walls here on either side, and they have windows earth facing down here. Right now we're in a night pass, can't see any light coming through them, but they're really nice optical quality lights for taking pictures straight down of the earth. This area in here is called the central post, the central command post. It has control. Did you I don't show the caution and warning panel and the
Go ahead and take the camera.
Yep. The caution and warning panel there, and all of the
old computers that they used to work.
Yeah.
Now we don't use these almost. We almost never use these anymore.
Okay, we'll continue
into the adapter.
Into the PKO. And if you want to swap to me, and I'll take the camera, and you can talk about which way you're going to go first.
You're going to go up?
So we're going to go up. And
hello, Alexander.
Hello. It's a surprise for me. Because I have finished only my physical exercise, and this moment I want to finish the rest. Okay.
So do you? Can you say hi? Say hello. Hello.
I can say hi, hello for everybody who will see this movie. Sorry.
Okay, so we're in the PKO, and we're looking.
So this is the PKO is just a junction. It's the equivalent of a node for the US-OS segment. Basically, it's a spherical module, part of the module where you can attach to 4 different sides, and you have modules that are used for different things. One of the things that we use this module for is for EVAs, and that's the one behind Drew, and we will go there later. But before, I want to show you this one. We're going to go down to see my Soyuz, the one that Drew and I came up with, and just very quickly.
And you said already that this is meme 2. I don't know.
I haven't said that.
Okay.
So this is called the mini research module number 2 in Russian, MEM2 MEM 2, and in the US we usually say MRM2. As you can see, there is a lot of stowage everywhere. This is true all over the space station. We always have stowage in every available surface. There are 2 older spacesuits here that I don't know if you can see in the view. the Orlan spacesuits are used for the Russian EVAs. These two are the older models. They're not used anymore. They're just here for storage. This is where they're kept. And then we go more inside. And so welcome to this is Soyuz MS-13. There were some concerns on some people that the number 13 is bad luck, but luckily for me it's always been a lucky number. In Italy 13 used to be a big win in a lotto-like game, and also my fighter squadron was the 13th squadron, so all good things for me. And over here basically the design is identical to the Soyuz that we just saw. The arrangement is slightly different because instead of having the spacesuits here, they're put here on the side. The three spacesuits that in about a month I will be going back down in. And then again, tiny space for the descent module down here. And we can go back up. And we'll fly into the SO1, SO1. If you want to swap now, you can guide them into the progress. Okay.
Okay, this is SO1, and I don't even know what do we call it in English. I don't know. But SO1, and really only the Russian nomenclature matters. But this is used as an airlock, and here are their two Orlan spacesuits that they would make a spacewalk with. Our Russian colleagues also keep a lot of their clothes and personal hygiene items in here as well. And we have a Progress resupply vehicle that docked earlier a couple weeks ago, and still has a lot of offloading to do. But you can see all the containers stacked inside there, and they slowly unpack those over the coming weeks and months because it stays docked. This one particular will stay docked for several months. All right, so we go through the out of SO1 back into the PKO. We'll do another 180 with the camera, and then into the FGB.
I think they call it DC1.
DC1 in English, yeah.
Yeah. Docking compartment.
Actually, why don't you go that way, and I'll take it.
Okay.
Okay, go ahead.
Okay. Now, this to me is a little bit like going into a living museum, because this is the oldest piece, the oldest module of the space station. It's currently probably the oldest human object orbiting the Earth, because it was launched in 1999, celebrating 20 years this year, or actually having celebrated already 20 years. And if it flew by itself, it was launched as a single spacecraft, and it flew by itself for several months before being docked to Node 1. And again, this is just like the other modules that we saw, is an exact replica of the Meir space station modules. This one specifically is called the FGB in English, and it's basically a support module. Behind this panel, just like on the deck, there's a lot of storage. Some systems, not many, but definitely this is the main compartment for storage for our Russian colleagues. However, because it was built in Russia but paid for with a cooperation with NASA, I think that a lot of this, about half of its compartment have now NASA storage in it. The way I see it in my mind, every time I think about this, I see a ladder, because this is how I move into it, just going down this ladder this way. So somehow, even when I'm on Earth and I think about this, in my mind, it's always been a ladder going up. Drew, what are you showing them there?
I was just showing, these are mission patches from the Soyuz. So we have expedition patches for the ISS expeditions, but also have patches for each Soyuz crew. And these are some of the historic ones that have docked here in the past. Many people we know.
So this is obviously a very, very busy compartment in terms of stowage, but crazy enough to, even though it sounds crazy, there is an order to this. And usually when we have to go grab something, we know behind which panel or at which height we have to go grab things. Now the only part of the space station of these modules, excuse me, that doesn't have anything on the deck is right here, because this is where our Russian colleagues take their hygiene breaks. So there's a big mirror. Probably the biggest mirror on the space station is right here. Yeah. I never thought about that. And these containers that you see on the side, these are where our Russian colleagues have their personal hygiene items. And so what happens is that they come here, they close this hatch, partially close this hatch to get some privacy, and then they can shower, clean up in the morning, and we know when the hatch is closed that's what's happening. From here, we are going to go into one more docking module, which is called the MIM Adin, or MRM1, Mini Research Module number 1, and it's a little bigger in terms of length, but very tiny. And for me, it's a sweet memory because it's where I docked my first time in 2013 with Expedition 36 on Soyuz TMA M9.
I'll follow you down into there.
Oh, yeah. There is not a lot of space in space.
And I'll stay up here in the GA.
Yeah, I'm just gonna show. Right now, as you can see, this module is being used mostly for stowage. There is some science going on the side. That's why it's called the Mini Research Module. But because there is nothing docked currently on the docking compartment, which is at the very end of this module, they use it for stowage. Because again, you have to think that every time something comes up, it has to go somewhere, and we have to have stowage to last in case something doesn't dock. So we have to have redundancy. That's why there is so much stuff on the space station. So if this docking compartment had a Soyuz or a Progress right now, you would see that part completely emptied out and a spacecraft docked at the very end. This is the very first module that I flew in, so sweet memory back from 2013 again. And Drew, back to you. I'll take the camera and we can fly. You can guide me through the PMA.
Okay. Well, we'll go here through the GA. The GA is what actually attaches the Russian segment to the US, the USOS, the US operating segment. So we're going to go now transition. We'll go through the PMA, and we're going to pass a bunch of stowage, a bunch of NASA US stowage stowed all 360 degrees around us in the PMA.
Hey, Drew, because this is probably easy to get lost, where is the Earth right now?
So the Earth right now would be straight through the camera, through your back, all the way down to down below you, behind you. So it doesn't come easily. You have to think kind of hard about what we're doing, which direction is up. It's very easy to get disoriented, especially I find in the Russian segment, because it's a lot more. There are a lot more confined spaces and a lot less orientation clues than there are in the way that our modules are built. So I'm going to back my way through here into PMA now, and we'll see stowage 360 degrees around us. This is where we keep a lot of we call them pantries and warehouses, a lot of our common use items like towels and wet wipes and dry wipes and nitrile gloves and things that we use a lot. are located right in here, so it's easy to get to. When we run out of one thing, we have another backup right nearby. We can take another CTB. This is a good place to demonstrate something common like a hygiene towel. Here's a container full of hygiene towels, and this is where we what we use to wash every day. Foil bag that has a towel impregnated with soap already, and we keep that right here so it's in a convenient location. These are all contained in bags called CTBs.
Cargo transfer bags.
Cargo transfer bags. All right, come on through, and this puts us into Node 1, another one of the old modules, or old original models of the ISS, and now has been converted now to where the primary place where we eat. This rack right here is the galley. It's one of our favorite racks in the whole ISS. It has our potable water dispenser, and maybe I should just demo fill in a bag real quick.
Totally, yeah.
So our food is stowed here, and we have food that we share, and there's food. We also have our individual containers of food, and I just grabbed this one. It's Tropical Punch. We'd come over here to the water dispenser, the potable water dispenser. I would dial up, oh, I need 250 milliliters in this. I call this the safety. This allows you to dispense it so you don't accidentally dispense it into your face. I want ambient water versus hot water, and then the bag will fill up. Then once it's full, I'll grab a straw. I guess I could have picked less than 250, so it takes so long to fill up.
But at least now you can drink it though. Otherwise it would have been too sweet or too syrupy.
Yeah. And then now we don't always play with our, well, yes we do. We do. We play a lot. But anyway, that's how we get a drink.
Drew, let's destroy one of the conspiracy theories about our table. One thing that I like to talk about is, why do we have a table in space?
Well, we still need a surface to work on things, but what we use is a system of Velcro, tape, and clips to hold our food in place. So here's a turkey tetrazzini that we had set aside to bring to Sasha because he really loves turkey tetrazzini. But once we reconstituted and ate this out of the bag, we would maybe put a clip on it and then use the Velcro here to stick it. Or we have this tape with the sticky side up, and it doesn't take much to make something stick to this, and it stays in place, and it just gives us a surface to stick things to. A couple other things to point out here, that we can keep food chilled in these Merlins that were actually designed for science, but they allow us to use them for our food and keep drinks cold. And then we have food warmers to put food in and warm it up. So this kind of food doesn't require reconstitution. It's already ready to go. They're just like military meals ready to eat, MREs, and this is where we would heat it up inside here.
This is all new to me. When this galley is pretty new. It didn't come. It hasn't been up for very many expeditions. Back in 2013, we didn't have it. We had to use a separate food warmer, which was in the lab, together with the water distribution system was also in the lab. So we didn't have a galley style node. This is much nicer, I think.
So this, an example of a food container and food stowed in. This is my favorite one. We call it lickies and chewies, an army term, but it's my favorite dessert.
My favorite Bob is the surf and turf.
Surf and turf that has all
the meat and fish.
All right. Well, why don't you hand over to me, and then you can show Cygnus in the airlock. And I'll shoot it from up here. So we have. Well, Tom, why don't you mention that we have two vehicles right now, and you're going to show Cygnus.
Yeah. So about a month ago or so, we captured Cygnus 12. again, for those that like history, details, and history and stories, I was the one that captured the first Cygnus demo about 6 years ago, and now we are Cygnus 12, so about an average of 2 Cygnus per year. And this one was captured by Jessica, I believe,
Yep.
to get assisted by Christina. And it is unique in its own way because it's the biggest Cygnus to date. It has 4 different levels of racks with cargo, and we have been working for the past month or so taking cargo out. We are almost done with the cargo out, and we're starting with the cargo in, which is going to be it's going to be all trashed when in about 25 days or so we release it to burn into the atmosphere. I'm gonna demo how deep it is here and going down into it. So here's the first level, second level, third level, and the fourth level is already busy with trash. So I'm gonna stick myself into it to show you just how deep we can go. And I'm currently, I'm in the lowest part of the space station. This is the closest I can get to Earth from down here. And my Soyuz, I guess, is the highest point you can get to on the space station currently.
Yeah.
So before we were in the highest point inside the space station, and this is the lowest point. As you can see, a lot of space to strap cargo and trash. Some of it will be over here, and then something very cool about this vehicle, and I think is really cool. After we close the hatch, we will install a delivery system so that during the descent burn, the Cygnus will release into orbit some payloads that will have time to perform some science for paying customers. So just another way to gain access to space is through this delivery system up here. And now, thank you. I really appreciate, Drew, you giving me the voice for the airlock. This is one of my favorite places on the space station. Even though right now it doesn't look like much of an airlock, because we are in the middle of loading and unloading 2 vehicles, and in about 2 weeks we will be performing EVAs, but not before we release one of the cargo vehicles that we will see later. So right now we're using the airlock as a temporary storage location. But when this is not a storage location, this is the temple of extravehicular activities. As you can see, to my left and to my right, we have 2 fully installed spacesuits. This is actually Drew's spacesuit for the past 4 EVAs. This is my spacesuit for the past 3 EVAs. And in the same configuration that we left them after performing 3 AMS EVAs, which is a story for a different time. Now behind me, invisible today, but behind these boxes, there is the actual airlock, the one that we close, and which will give us access to the vacuum of space. This is very unique to me and dear to my heart for several reasons. First of all, because again, it's where we do our EVAs, which is very prestigious, very hard, but also incredibly exciting as an activity. And I'm sure that Drew, you agree to that. Especially for us, we did 3 together as a crew. But also because it's quiet aside, it's only used for that. So just a very unique, special place. Now, Drew, I'll take the camera and you can lead me through Node 3 and tell me Node 3 and Cupola and tell me why it's a special place.
All right, well, so now we'll continue from Node 1 into Node 3, where I think we have 2 exercisers going on right now. Christina and Jessica both exercising. Jessica on ARED, our resistive exercise device, weight training, and Christina is on a treadmill called T2, and she's actually doing something a little bit different, a little more unique. She's doing a backwards walk on the treadmill just to kind of as she's just a couple weeks away from returning to Earth. It's thought to help a little bit with some of your balance muscles when as we return. Kind of requires a little bit extra coordination. So we'll fly through here. Now we're gonna fly through.
Might be a little harder with this table here.
Yeah, but we'll go underneath. We'll go down low.
Will that help? Here, I moved it.
Yeah. So the treadmill T2. We're gonna continue. And then the resistive exercise device that looks like Jessica's just finishing up on. Here, where
I'm going to show the T2 for a second, just to give it a look. Just the fact that it's actually horizontal, the Earth is this way, so my crewmate Christina is actually running parallel to the ground as opposed to vertical.
And then I guess this is important too, the demonstration of the bathroom here, the toilet, the WHC. It uses a lot of the same hardware as the ASU, the Russian toilet. It's a Russian design. We have a system that's integrated with it to take urine, collect it, and convert it into drinking water. And so that's an aspect that's unique to ours, but most of the hardware for the actual collecting of the solid and the liquid waste is Russian. And there are components in here that occasionally break. We've had our fair number of repairs on this mission so far. And those are all behind these panels here. And then there's a pretty complicated control panel for what at home is just a simple device that you just flush with a single handle. This has a lot of buttons and a lot of instructions in case something goes wrong, and what to do if you get a red light, the dreaded red light on the panel when you're going to the bathroom. So for urine, we have a tube that collects it, and this takes it through a system that mixes it with some chemicals, and then it eventually is processed in the urine processing assembly, which is down here underneath us, and that gets converted into drinking water. And then for solid waste, you can kind of see how this looks a little bit like a toilet. Both the hose and the solid waste container use suction to make sure that everything goes where it's supposed to. But basically, solid waste is collected in a bag, and then that bag is collected in this container down below here, and we change that about every 7 or 8 days as it fills up. And then we discard the can itself in a vehicle like Cygnus that will burn up in the atmosphere. All right, moving down here, this is another thing that makes Note 3 important to us, in addition to the toilet and the exercise, is the cupola.
You want to show a little bit of ARED, just to give them an idea of what it's like to exercise on it?
I think we'll shoot that as another separate thing.
Okay.
Right, just keep going. Okay, so yeah, another thing that makes this module special, unique, is the cupola. We're on a night pass right now, so not much to show outside. We may have to come back and shoot cupola
Sure.
day pass.
How much time do we have until the next day pass?
Until a day pass? Not too long. Maybe.
Good morning. We're really on
15 minutes
Yeah,
or less.
this is Jessica. I was calling to check in on the status. There were some open items. I
Sunrise,
called down earlier when Courtney was
over-
on, and I was looking for some answers to the
We're in North
Star
America.
Trek questions I called down earlier. If you need
You want
those stuff,
me to
I can
continue
give
into
them to you.
PMM then?
Yeah.
Okay, so PMM is where we stow a lot of cargo, and we'll go, and we also use it for our personal hygiene. So let's fly in here.
We expected them to be. Unfortunately, they're not. So just the wrappable and soft goods. No constraints on how you do that.
Okay, so it's not.
So-
they don't have to. Each individual bracket doesn't need to be wrapped in soft goods, but just
Right
like
now,
goods and
PMM
blankets.
is fairly full of all kinds of stowage. We stow all kinds of things in here. One of those things is trash. All these bags back here represent different types of trash. We sort our trash according to whether it's wet, whether it's dry, whether it's hardware related.
Okay, copy.
and all those get labeled. So this is a bag of dry trash, and those bags get stowed here in the end of PMM, and then when it comes time, we'll eventually load those in the Cygnus vehicle, and all that, along with the waste from the waste and hygiene compartment from the toilet, will also get loaded into it, and that will burn up in the atmosphere. We also use this to, much like the Russians do their personal hygiene, keep a lot of their clothing in modules that have other purposes. This is the same for us. Our gym clothes are stowed in here, and we dry them out here. And we also keep our towels and washcloths in here as well, and we do our showering in here. And when we do need to shower, we would come to this part right here. So each of us has a station where our stuff is hanging, and we keep things in mesh bags like this. And then we pull the curtains down to keep all the water from our shower from going everywhere. And basically, we take a sponge bath. We take that towel that's impregnated with soap. We add water, and then we just wipe down everywhere, and then we hang that to dry, and it dries out. And so we use that for 2 days, and then we'll discard the towel. But this is how we get our privacy on all 4 sides and keep from getting the cargo covered with all of our dirty water.
Let's fly back to Node 1, and then we'll go into the lab.
Okay. Fly under.
And Jessica, that's correct. We're going to need some words with the ISS program office on that one. So I would expect the next one.
Okay, great. Well, thanks for looking at the money. It was really nice to close those steps up. Appreciate it.
Okay.
No problem. We'll be here.
So welcome into the lab. I would say that just like the SM, the service module for the Russians, is the heart and soul of the Russian segment, I would say that the US lab is the heart and soul of the US segment, because it has most of the systems that keep us and the station alive. So underneath these racks and on the sides, there's a lot of science going on, but there are some of the main systems that keep the atmosphere clean, that keep the space station pressurized, and the temperature control. It's all in this module. But we also have a lot of cameras over here that we use for internal photo documentation. A lot of cameras are obviously in Cupola for outside documentation. And then this is also where we have what looks like 2 robotic stations. One is the actual robotic station. This is what we use to control the Canadian robotic arm, Canadarm2, both doing EVAs and cargo ops. When we do track and capture, we do it from Cupola. We didn't show that. That's where an identical station is situated. And on this side, we have a simulator. This is what we call the robot station. This is these 2 computers run a simulation of different scenarios where we use the robotic arm. So the controls are identical, the visuals are very similar, just in a smaller scale. Let's continue here. A little bit of a legacy from a different time where we didn't have Node 3 is that over here in the lab we have our bicycle, which is anything but a bicycle because it only has one. It doesn't have a wheel, and it doesn't have a seat, and it doesn't have a handle. It's called CIVIS, which I honestly don't know what it stands for. It's an acronym for something, but the way we use it is that we rotate it, we lock it in this position, we strap ourselves in with this belt, and then we lock our feet on the pedals with just regular biking shoes, and then we have a computerized system that determines the load, and we have different profiles that are individually designed for each of us, because of course we have different capabilities, different needs, so each of us has a different profile loaded, and each of us has different profiles for different time of the week, so that we can choose how hard or how easy we want to go, and then we can fold it to get it out of the way. Another unique feature Underneath this panel, there is a very high quality window that faces straight down towards the Earth, and we try to use it as much as we can for Earth observation. I actually haven't done much, but I know that Drew, Jessica, and Christina really love to take pictures from this window. The quality of the picture is just outstanding. Everything else around me here is payloads, which means science, scientific labs. Each one of these racks, that's what they're called.
Now there's still about a quarter CTB space left in there. So
Each individual rack is basically a different laboratory. This one is FIR for fluid physics. This one is SIR for combustion. Up here we have an express rack, which is basically a modular system where we can install all kinds of different experiments. This one is for material sciences.
Sorry.
Yeah, that's okay. This one is for material sciences, and then more express racks, so more individually tailored experiments. And then over here, the MSG, the one of the two main glove box that we have on the space station. Glove box, which means behind this panel there's a completely sealed compartment that we can access through gloves in order to isolate the science behind it. We have another glove box later on. We'll see it in the Japanese module, and then different experiments may have individual glove box contained inside. There is another one in FIR, there is another one in Columbus, and another one in the Japanese module. So lots of different glove box for science. And then we're gonna swap again, and Drew, why don't you guide us into node 2?
Okay.
Spaceship used into for Jessica's stowage.
Okay, we're in entering node 2, so we're getting very close to the most forward part of the space station. The most important thing here is that it has our 4 crew quarters. There's one overhead, that's where Christina's living right now. One here on the port side, where Luca's living. Down here in the deck, Jessica, and then on the starboard side, there's mine. And we have each of our name tags on our quarters so that we don't forget whose is whose. So there, yeah, we go ahead and pan through all of them there.
Jessica's name tag is covered by my CTB there.
Oops.
Jessica and mine over here on the side. So basically, Drew and I sleep standing up, and Christina
Sleeps on the
sleeps
ceiling.
on the ceiling, and Jessica probably has the one that would be the most classic way of sleeping on the deck, if it wasn't that she's actually on the side. So this is at the same time it's our living quarters, our crew quarters, where for privacy, but it's also a working place.
So so we have a workbench here, and it has our tools deployed at all times that we use commonly: markers, eye protection, gloves, scissors, Velcro, pliers, wire cutters. They're all here, and we have a drawer full of tools back in Node 1 that has just about everything you can think of. Now, Luca had mentioned we have 2 vehicles docked to the ISS right now, so places a little bit feels like we're just moving in. So we have stuff stowed everywhere right now. So it's not usually this cluttered, but for the last couple of weeks, this has been the life that we've lived here in the clutter of cargo operations for 2 simultaneous vehicles, SpaceX and Cygnus.
So why don't you show me the next vehicle that we have here?
All right, so Dragon arrived at the beginning of December. And this vehicle is unique because we don't send this one home with trash to burn up in the atmosphere. This is the one we use to return science, cargo, hardware back to the ground. This one will recover under parachutes and land in the Pacific Ocean and be recovered. So we send things back that we want to keep in here, and so we're in the process of packing it up right now. So I will go ahead and go down into Dragon, which right now has got we have a lot of cargo operations involve a lot of foam and a lot of bubble wrap. But I say fly all the way in here past all that and just have a look around the empty cargo compartments as we fill it up here over the next couple of days. A lot of science return, items that need to be kept cold. We pack them in ice, and they'll be in the ground and unpacked within a day or so. All right, so we go to, make the switch. Oh, and then interestingly here, then these are the two docking ports. They're covered with stowage right now, but the two U.S. crew vehicles, Boeing Starliner and SpaceX Dragon, will dock to ports that are up front of the space station, and then on the Zenith side, that's at the top of the space station here, these two docking ports, and we hope those will be used here in the next couple of months.
Let's go into Columbus. I'll take over.
Okay. I think Jessica's packing a bag there.
She won't mind.
I don't mind. If you do this for me. Throw that in the bubble right behind you.
Absolutely. Yeah, a demo of cargo operation. This goes into the bubble bag.
This is bubble here.
Yep. And this is Columbus. Obviously, the pride and joy of the European Space Agency. This is the contribution to the ISS program by ESA. We have also a lot of cargo here going on, but this is quite typical right now. Columbus is first and foremost a lab, so the systems are on the deck. They take over 4 different racks of systems and stowage, but then on the sides and also on the deck we have labs, different kind of labs. So forward is this way, aft is that way, and some of the thing that makes this module special to me is that this is where we do a lot of the human research. The 2 modules at the very back are called HRF module, Human Research Facility. So to me, when I think about Columbus, I will always think of doing research that really interests the human physiology. Another thing that makes it dear to me is that it was built in Italy together with Note 2, Note 3, and the Cupola. So obviously a little bit of Italian pride. The Cygnus structure is also built in Italy. So right now there is a lot of Italy here in the space station. We have some of the very advanced facilities that we have here. Right now we have a 3D printer that actually prints in biology tissues right behind this. Until a few weeks ago over here, these are greenhouses where we grew salads. Drew, Jessica and Christina were the main people involved with that project. I was just one of the tasters. And 2 different facilities with different lights. This is how we explore in the future what kind of facilities we need to go beyond low Earth orbit and explore the planetary system using stuff that we can grow on the space station. And then of course, like we said, a lot of different cargos because of the cargo ops going on right now. Drew, why don't you show me the Japanese module?
Okay. Go this way and we'll make the switch. right. Okay, this is JPM, or the Japanese Experimental Module, Kibo, and it was designed and built by the Japanese Aerospace Exploration Agency. And like Luca described Columbus module, while we're on board, he's the Columbus specialist. He's the one that's primarily doing the European Space Agency work. We both do work over here in the Japanese Experimental Module. I was trained as a GEM specialist, and so this is the module that I'm primarily responsible for, since we don't have a Japanese crew member on board. And it's a little bit bigger than Columbus, and it, much like any module, it has both systems racks and it has payloads racks, experiments going on them. One of them that I have that arrived on HTV is called the Cell Biology Experiment Facility, CBEF, and I just installed this, and it's not fully installed yet. But you can see by the number of cables and boxes on the front of this thing, it's fairly complicated. Like good Japanese equipment, it is very well designed, very well built, and it's been a lot of fun and challenging to get this installed. And we're looking forward to getting it running here in the coming weeks. But there are a lot of different experiments like this built into the different racks. And when we talk about racks, I think it's probably worth talking about how all the modules, if you look outside the space station, the pressurized modules of the ISS are round cylinders. They look like cans of soda. But you see the cross section for us on the inside is actually square, and that's because we have these racks that are installed, and each of these racks are flat in the front and they're rounded to match the outer shell of the space station, and it gives us this square shape on the inside. But each of these racks can be taken out and replaced with something else, and so maybe it's a payload rack sometime, but maybe eventually it has to be replaced with a systems rack, or a systems rack needs to be replaced because something has failed and the entire thing needs to be changed out, or we take one out and we turn it into a space that we can use for cargo, because all the other modules that we showed you where there's cargo stowed, we have racks that are exclusively made just for stowing things, like this one here above. And I'm fly and show what. So these are what a neatly stowed rack looks like. This is not overfilled by our definition of the word, but even the Japanese experimental module is not immune to being stowage on the deck here. We have a lot here from the vehicles that have arrived, so normally this would be wide open ideally, but we do have a lot of stowage here on the deck of the Japanese experimental module as well. Maybe worth showing also a Melfi, which is a freezer that science samples can be frozen to all different temperatures. I don't know what's some of the lowest temperatures in Melfi that you've seen.
Minus 95.
Or is that polar? The different freezers have different capabilities, and this Melfi freezer has 4 compartments in them, and we're frequently taking samples in and putting samples in, taking samples out. We also do a lot of our public affairs events here because it is one of the more clean modules, and it happens to be also at this as a nice backdrop here. For us to do public affairs events, and it's not in the way, whereas if we do them in the lab, it's right in the middle of everything. There's a robotic workstation in here for the robotic arm that's on the outside of the gem. And then behind me is another piece of equipment that Luca and I are trained on and use frequently. It's a small airlock for putting payloads in and out, not for putting astronauts in and out, just payloads. And there's a slide table inside that slides in, and we mount maybe a satellite deployer or a small experiment that needs to go outside. It goes in, they depressurize the airlock, the small robotic arm on the other side grabs onto it, and then installs it on a platform that's called the Jeff, that's just on the outside of the gem.
And it has an attic.
An attic, yes. So the attic JLP, the
Go ahead and fly up and show.
okay. All right. Yep. Let's.
I'll follow you.
So this is JLP, which is another stowage module here in attached to the gem, and it is filled with stowage, a little more neatly than PMM, but nevertheless, it still looks like it can look like a mess, but it is actually very well organized, and you can find things by location codes. Everything has a place, and it has a nomenclature, and we think of things in terms of how they fit into ISS coordinates. So starboard, port, aft, and forward, and it's actually very easy to get confused on which direction that is. So they're written right on the different bulkheads, so that you know which direction, which wall, for lack of a better term, you need to go to. All right, so Luca, this is what I was thinking then, but we also need to go shoot the cupola again. But let's do this. Let's do. I'll hold, and we'll do a fly through where you're out ahead, just flying through all the way back to the Russian segment, and then we'll reverse it, and then we'll do a fly through back this direction where you're holding it.
Okay.
So let's go up here.
And we do it with me facing the camera, or with?
Yeah, is facing the camera as much
and going
as you can,
backwards.
like a B-roll.
Okay.
If you, yeah, whichever you can move around. Okay. So, and you can. It's not a tour per se. Just
just fly by.
B-roll, but you can say things as we go. Ready?
Let's go.
All right. All right. Let's fly out of JLP. I'll say where we are as we go. And through the gem. Do some flips if you're feeling good. There you go, that's good.
The vice president came home, reported, and said, Zelensky's done a lot to fight corruption. I think we should release the aid to basically before I let you.
Okay, and I'll fly forward, and we'll go to Columbus.
I almost want you to respond to one of your colleagues, Bill Cassidy, Republican senator from Louisiana, sort of implied in our Senate piece routine.
Okay, we go to Cupola.
Yep.
We can check Cupola for me. We'll fly through again. You want to talk about the cupola?
So Cupola is obviously one of the places that astronauts love for many different reasons. But I suppose that the main reason why we like it so much is because it gives us a 360-degree view through the 7 windows of our planet, Earth. If you ever heard of the overview effect, this is where we get it. We understand how fragile Earth is because we get to see about 6,000 kilometers of it in one shot, and we have a very clear view of how thin the atmosphere is, how fragile our planet is, and sometimes we think that the most fragile thing on Earth is probably us. We are the most fragile and the most dangerous thing at the same time, and this view is just so unique and such an incredible, humbling place to see it. It makes you feel really small and really part of something big at the same time. Now, operationally, we actually do use it. Right here, we have a robotic workstation that lets us control the robotic arm, which is right there right now. And through that robotic arm, we capture and berth several cargo vehicles that come to the space station to refurbish all our needs: food, water, different kind of gases, experiments, and all sorts of cargo. And as you can see,
shows signals here too.
yeah, and as you can see, the Earth is just an incredible view. And no matter how many times you come in here, no matter how many times you look outside, the view is never the same. It's always different. The light might be different, the time of the year might be different, the clouds are always different, and with a little bit of luck, we will be different too.
I want to have you demo the window open close.
So, in order to prevent too many meteorite strikes, we try to keep it open during the day so that we have a good view of the Earth and that we can enjoy the sight. But when nobody is going to be watching it, we like to close the windows. And so we have a very simple manual system that works perfectly well. And this is how we close the window. This is the main window, window number 7. And then on the sides, we have a similar system to close the shutters and prevent micrometeorite strikes from damaging our windows.
Okay. And then, if you would open Windows 7 again. And then let's get a view now with both of us in this camera with the view of this on looking out.
Yep.
Both of us on this side.
Absolutely.
Right? So thank you for joining us on this 2020 tour of the International Space Station, the 20th year of the ISS's continuous human presence on board the ISS. It's been our pleasure to show you around our home. Constantly a work in progress, constantly a work of art, a work of science.
I hope you enjoyed the tour as much as we did. It was really our pleasure to be your guide tours. I'm European Space Agency astronaut Luca Parmitano.
And I'm NASA astronaut Andrew Morgan.